Now we're going to go into how to mark our hypothesis. So when you were having this explained in class, you learned that a hypothesis is looking at when you state how you're going to change your independent variable. In other words, in this, we're going to change the cooling speed. How you think it's going to affect your dependent variable, crystal size. Now, you cannot do a hypothesis unless you filled out your variable table, in case you hadn't noticed. And it's also very important for you to notice that when we talk about hypothesis, if you don't say how you're going to change something, you can't predict how it's going to change something else. I can say that yes, changing the speed of the car will change what happens to me when I'm in a car crash, but I won't be able to make a really definite prediction unless I talk about when I increase the speed of a car, I will get squished more in a car crash. Okay, I've got to give it direction. So that's the important thing to note with the hypothesis. They need to have that there. So we're going to go over here to where I've put some examples of how to do a hypothesis. And there I've got the basic outline above, and I've got some color coordination happening here. To get a sea level in a hypothesis, you need to show two things. You need to tell me how you're going to change and predict how the dependent variable will change because of what you've done. So in our hypothesis, that simply comes down to my independent variable, what I'm going to change it, how I'm going to change it, bigger, smaller, whatever. That's my independent variable, and how I'm going to change my dependent variable as well. So here I've got if the cooling speed, that's my independent variable, see here, independent variable, cooling speed, dependent variable, crystal size. If my cooling speed is decreased, I've given it a direction. So if I decrease it, what am I going to think will happen with the crystal size? Then the crystal size, there's my dependent variable, will be reduced. There again is another direction. If you've got both of those things happening there, then you can tick off your sea level for your hypothesis. Now to get a B or an A, you have to give me information to make it plausible. You have to talk about scientifically why you think it's going to happen. Okay? To get a B, you just have to give me some reason that basically backs up what you're saying. To get an A, you have to talk about it in detail and give me what we call a justified prediction. In other words, the theory that I've taught you about whatever the topic is, you have to use that theory to justify or explain why you think this is going to happen. So for a B level, an easy why, without going too far, would be, why is it going to be reduced? Because the particles, because I've taught you about particles moving around, the particles haven't had time to organize themselves into a large crystal. That's part way to a full answer on why we think it's going to actually be smaller. So to take it up to the A level, we have to actually explain what's happening to our independent variable and our dependent variable in a lot more detail. In other words, getting down to either what's happening to the energy, what's happening to the particles, that really explains what is why we are seeing what we are seeing. So I've brought across our previous B and C level stuff, and then I've explained it in more detail here. So first of all, cooling speed is decreasing. That is our independent variable. I've then gone and explained it in a little bit more detail down here. What's happening when we change our cooling speed? Well, we're actually changing how the particles are slowing down, or speeding up, but in this case slowing down, and they are stopping moving. So I've explained what's happening when we change our cooling speed. We're affecting the particles. Yeah? That's what we're doing. We're affecting the particles. Now that in turn will affect our crystals, because our dependent variable here is our crystals and how they grow. So now I'm trying to explain how that's going to affect our crystals at a particle level. They have more or less time to rearrange themselves and organize so that they can actually grow. And that's because they're moving from a liquid state into a solid state, and the speed at which they move from a liquid to a solid is going to determine how organized they are. Now, there's several different ways you can actually get to an A level, but basically you have to explain what's happening to your dependent variable and your independent variable in great detail. Not just basic detail, in decent detail. Energy, particles, get right down to the specifics of what I have taught you. If I have taught it in class, I expect it to be here in the hypothesis if you want to get an A level in it. And if you're a bit unsure about how to get to that level, then that's certainly something that's going to be in our discussions when we're actually developing our hypothesis at first, because you will have been taught enough theory to develop a hypothesis based on that theory. So that's questioning and predicting in a nutshell. Developing a hypothesis, give it a go, and then come back and give it an extra go to improve it.